Welcome to today's comprehensive AI deep dive broadcast on UGTP. Let us begin with our fast headlines. In a historic week for computation, the biggest artificial intelligence breakthroughs did not arrive one at a time. They hit simultaneously across every major platform. First, Microsoft launched MAI, a family of 7 foundation models built entirely in-house without third-party distillation. Second, Apple took center stage at WWDC 2026 to unveil a ground-up architectural rebuild of Siri powered by Google Gemini. Third, Google announced 24/7 autonomous search agents, transforming its core engine. Fourth, cybersecurity researchers uncovered agent jacking, a prompt injection exploit targeting coding agents with an 85% exploit rate. Fifth, GPU AI released open-weight GLM 5.2, scoring 62.1 on SWE Bench Pro at nearly 7 times cheaper than proprietary flagships. And finally, Linus Torvalds released Linux 7.1 stable and opened the merge window for Linux kernel 7.2, retiring 36-year-old Intel i486 legacy code while unlocking frontier AI hardware acceleration. Hello everyone, and welcome back to UGTP. Settle in, take a deep breath, and let us explore exactly what these massive shifts mean for developers, enterprises, and the future of technology. Our first deep dive brings us to Redmond. For years, Microsoft's artificial intelligence roadmap appeared inseparable from its partnership with OpenAI. However, at Build 2026, Microsoft revealed a profound strategic pivot. The MAI family of 7 foundation models, engineered entirely by their in-house AI superintelligence team. Crucially, Microsoft emphasized that these models were trained from scratch with zero third-party model distillation. The flagship reasoning engine, MAI Thinking 1, utilizes custom reinforcement learning algorithms to execute complex mathematical and architectural planning. Alongside it sits MAI Image 2.5 for visual generation, MAI Transcribe 1.5 for acoustic parsing, and MAI Voice 2 for natural speech synthesis. Why is Microsoft executing this massive decoupling? Hyperscalers have realized that relying on external licensing fees erodes cloud margins. By integrating their custom Azure Maya silicon directly with proprietary foundation weights, Microsoft owns its entire intelligence infrastructure, from silicon to software, insulating its enterprise cloud empire from third-party bottlenecks. Nowhere is Microsoft's full-stack autonomy more apparent than in developer tooling. Alongside their flagship reasoning weights, Microsoft unveiled MAI Code 1 Flash, a specialized model engineered for lightning-fast code generation. Rather than reserving this breakthrough for research benchmarks, Microsoft immediately began deploying MAI Code 1 Flash across all GitHub Copilot subscription tiers. For software engineers, the impact is transformational. Operating at over 150 tokens per second, the model dramatically reduces latency during inline autocomplete, automated unit test generation, and multi-file refactoring. In enterprise benchmarks, MAI Code 1 Flash demonstrated superior syntax retention across Python, Rust, and C++ repositories. This aggressive deployment proves that developer IDEs have become the primary battleground for frontier artificial intelligence, where speed, deep workspace context, and seamless execution dictate market dominance. Let us examine how mobile ecosystems are responding to this challenge. Turning our gaze to Cupertino, Apple dominated headlines at WWDC 2026 with an announcement that fundamentally redefines mobile operating systems, Siri AI. For over a decade, Siri was widely regarded as a rigid command-and-control voice assistant restricted to isolated tasks. Apple did not just issue an incremental update, they executed a complete architectural teardown. The rebuilt Siri maintains deep semantic context across your entire hardware ecosystem, including iPhone, iPad, and Mac. Under the hood, Siri continuously indexes personal data, understanding what is currently visible on your screen and recalling past conversations from weeks ago via a dedicated recall app. More importantly, Siri AI now functions as an autonomous agent capable of executing multi-step workflows across third-party applications. If you ask Siri to gather meeting notes from yesterday, format them into an executive summary, and send them to your engineering lead on Slack, Siri plans the API calls and handles the execution autonomously without manual intervention. To achieve this cloud-scale cognitive reasoning without compromising Apple's strict on-device privacy standards, Cupertino unveiled an unprecedented hybrid architecture. While on-device Apple Foundation models handle personal context, biometric encryption, and immediate OS interactions, Apple formed a historic strategic collaboration with Google. When Siri encounters complex cognitive reasoning tasks or frontier world simulation queries, it seamlessly routes the request to Google's Gemini cloud models under explicit user consent. This partnership represents the ultimate agentic operating system alliance. By combining Apple's unmatched hardware distribution and silicon neural engines with Google's frontier multimodal weights, the two tech giants have effectively created a unified standard for mobile intelligence. For iOS developers, new app-intense APIs allow third-party software to expose their internal functions directly to Siri's agentic planner, opening a massive new frontier for automated mobile commerce and productivity. Meanwhile, Mountain View delivered what tech analysts are calling the most dramatic core transformation of Google search in over 25 years. Built upon the blazing fast multimodal reasoning of Gemini 3.5 Flash, Google Search has officially transitioned from a passive keyword query engine into an active conversational task completion platform. The centerpiece of this monumental shift is the introduction of 24/7 search agents. Traditionally, staying informed required users to manually execute repetitive search queries every single day. Now, you can task Google's autonomous background agents to continuously monitor the live web for highly specific parameters. Whether tracking newly published research papers on sparse attention, monitoring real-time supply chain delta in semiconductor pricing, or waiting for enterprise software drops, your agent operates around the clock. When it detects meaningful changes, it compiles a synthesized briefing and pushes it directly to your dashboard. Combined with real-time voice Gemini Live Translate, Google is turning the search bar into an active digital workforce. However, as we empower autonomous agents to read repositories, call APIs, and execute source code, we inadvertently expose enterprise architectures to a terrifying new cybersecurity frontier. This week, security researchers disclosed agent jacking, a critical prompt injection vulnerability that has already impacted approximately 2,388 organizations worldwide. Here is how this insidious attack operates. Malicious actors embed hidden, obfuscated instructions inside fake Sentry error reports, repository commits, or issue tracker tickets. When an enterprise developer tasks an AI coding agent like Claude Code, Cursor, or OpenAI Codex to review the error logs and submit an automated bug fix, the agent ingests the poisoned log file. As the large language model parses the text, the hidden payload hijacks the agent control flow, instructing it to quietly exfiltrate environment credentials, inject malicious dependencies, or establish backdoor terminal access. With an observed 85% exploitation rate in unsanitized environments, agent jacking serves as a stark warning. Robust input sanitization and strict sandbox terminal permissions are now urgent existential necessities. If enterprise security represents a sobering governance challenge, the open source economics of June 2026 offer an exhilarating cause for celebration. ZPU AI officially released GLM 5.2, an open-weight frontier foundation model released under an unrestricted MIT license with zero regional limitations. GLM 5.2 achieved an astonishing 62.1 score on the rigorous SWE Bench Pro software engineering benchmark, outright surpassing closed proprietary flagships like GPT 5.5 at 58.6. But the true paradigm shift lies in its unit economics. GLM 5.2 operates at approximately $4.40 per million output tokens, compared to roughly $30 per million for comparable proprietary models, making frontier automated engineering nearly 7 times cheaper. Leveraging advanced minimax sparse attention architectures that slash per token compute overhead by 95%, GLM 5.2 proves that open weights are democratizing artificial superintelligence far faster than walled gardens can maintain their technological moat. Finally, let us descend from cloud abstractions and examine the foundational operating system bedrock running all this frontier infrastructure, the Linux kernel. Mid-travel across time zones, Linus Torvalds officially released Linux kernel 7.1 stable, while immediately kicking off the development window for Linux 7.2. This release cycle represents a monumental spring cleaning. Kernel maintainers executed a decisive hard cut, purging over 140,000 lines of obsolete code. This officially retires 36-year-old Intel i486 CPU support, alongside ancient ISA speech synthesizers and PCMCIA host controllers. By making timestamp counter and CX8 support unconditional on x86 architectures, developers have streamlined core instruction scheduling. In networking, dropping legacy UDP Lite and IPv6 module modes has significantly tightened kernel attack surfaces. Furthermore, landing a completely rewritten kernel-native NTFS driver brings delayed allocation and dramatic write performance directly into mainline Linux. Let us explore the frontier hardware capabilities arriving in kernel 7.2. For artificial intelligence engineers, Linux kernel 7.2 is an absolute powerhouse. First, it introduces expandable heap allocation for AMD Ryzen AI neural processing units, allowing laptops to dynamically manage memory for massive local AI models. Second, it deepens upstream driver bring-up for NVIDIA Nova graphics stacks, enabling full accelerated support for Blackwell and Hopper compute architectures. Third, initial boot support arrives for Apple M3 Max, alongside rugged Panther Lake CPU profiles and optimized cache-aware scheduling for multi-threaded processors. Once again, Linux proves it is the undisputed king of AI hardware enablement. That concludes today's comprehensive deep dive into the June 2026 AI megashift. We want to hear from you. Which of today's breakthroughs impacts your daily workflow the most? Drop your thoughts in the comments below. If you enjoyed this soothing breakdown, please hit subscribe, leave a like, and ring the notification bell. Thank you for watching UGTP. Settle your mind, stay curious, and we will see you in the next broadcast. Stay inspired.